In celebration of this channel reaching and surpassing 5,000 subscribers, here is a long-form video made in thanks to the subscribers of this channel for your continued support. I continued to be surprised at the growth of this channel and couldn't have done this without all of you. Many thanks, and onward we go. I'm still excited and having a blast researching and making my videos, and I look forward to many more years of telling you about the cool ideas and stories that I come across within the world of science, especially astronomy, and ultimately our progress towards answering the question of are we alone? It's one of the biggest questions in the universe from our perspective, and I really don't think we're all that far from answering it definitively. I believe that within 20 years there is a good chance that we'll finally know the answer to the question. But when discussing SETI and searching for alien radio signals in particular, there has always been a kind of elephant in the room. Detection is a two-way street, and the elephant is whether they can see us. We know that it should be possible for us to detect alien radio signals here on Earth, or in fact all sorts of biosignatures that point to life, so long as the signals are strong enough. This goes both ways. In theory, alien civilizations should be able to detect us as well. But in practice, this process is a bit trickier. It really depends on what equipment that alien race has and how close they are to us in space, and the same rules apply for us when looking for them. The one thing an alien race would know, however, assuming that they have powerful telescopes a bit bigger than what we have now, is that Earth hosts life. Life on Earth has a long history and has been affecting the composition of the atmosphere for billions of years. And by studying Earth's atmosphere, anyone in the Milky Way that's looking would see our atmosphere as it was at various stages in the not-too-distant past. Our galaxy is only about 100,000 light years in diameter, so they would not see our planet as it was during the time of the dinosaurs, but rather much more recently, depending on their distance from us. This is one of those rare cases in our universe where the distances do not seem so vast as far as geologic timescales go, but even still it would be very difficult to detect Earth from the other side of the Milky Way for a number of reasons. But for those that can detect us, the easiest biomarker for an alien civilization to see is our oxygen in the form of O2 and to a lesser extent ozone. While oxygen is not a dead ringer for the presence of life on a planet, it can be abiotically created. We do have an awful lot of it, an abnormal amount. They would also see our water vapor, and taken with the oxygen, that would indicate to them that complex life could exist here. With a sufficiently large telescope, they would in turn see CH4, methane. With those three markers taken together, they could reasonably infer that life was the probable source for those gases. But what else could they know? In a paper by Edward W. Schweiterman and colleagues, links to all papers mentioned in this video in the description below, they review all currently known biomarkers that we can search for to determine if an exoplanet hosts life. It's worth noting here, and the authors of the paper state it prominently, that these biomarkers are for our class of organic water-based life. There may well be alternative biochemistries that would have different markers, but we don't yet have a clear picture of how those life forms might work, and if such chemistries could ever result in intelligence. But in regards to an alien civilization looking at us, even if they were not carbon-based and instead based on, say, silicon, if they could build telescopes and spectrographs, they would have the scientific capability to know of carbon's complex chemistry and suspect that water and organics, both common in the universe, can lead to life. Organically based alien life similar to us would already know based on themselves. Many other potential biomarkers can be seen on this world. One example is variations in carbon dioxide levels that occur seasonally as vegetation cycles. Another would be the many other gases such as nitrous oxide and methyl chloride that, while they might individually be created abiotically, when you take them as a whole, life becomes the likely source for the profile. They might also see direct reflectance from our vegetation in the near infrared. Searching exoplanets for this biosignature is covered in a 2005 paper by Seager and colleagues, and the technique could equally be used by an alien civilization looking at Earth, providing they know what plant life is. But even if they don't, they might still see that some strangeness is happening with this world in the near infrared. But what of detecting our civilization through our technological markers? There are quite a few of these, and the more developed we become, the more important some of them will be as far as aliens spotting us, such as our waste heat when we start doing things like building Dyson swarms. That eventually would be visible at much greater distances than anything we're doing now, but as we are right now, there are several major technological markers that we produce. Before we get to those, it's worth pointing out that distance is key for aliens to detect us. We've only been technologically visible in a major way for about a century, give or take. Hypothetically, aliens within 100 light years might see the signatures of our technology, but they would see it as it was in the past. If they are close, say Proxima b hosts a civilization for example, then they would see us how we were a bit over 4 years ago. A civilization at 50 light years would see us as we were 50 years ago, and so on. But further out than about 100 light years or so, using any practical means, we become essentially undetectable. And the further you go from there, the harder it becomes to detect and study Earth at all. Within 100 light years, there are two main markers that aliens might detect and a few peripheral ones. Firstly is radio. We've been broadcasting radio waves for about a century, give or take. Aliens within 100 light years from Earth, in theory, might pick those transmissions up, depending on what equipment they have. But as a matter of practicality, they might not. The reason for this is that they would need some serious equipment to do it. If we took our own current equipment out to Proxima Centauri and looked at Earth, we would not be able to see the vast majority of our own radio signals. Our television and radio stations are simply too weak. The best chance would probably be radar, and even then the chances are slim. We have in the past, however, beamed out signals that were powerful enough, particularly the famous Arecibo signal. But the problem is that to see that signal, the aliens would have to be looking at just the right time to catch it, and they would have no idea it was coming. But that's just judging things by our own current radio capabilities. They will no doubt get better and more sensitive, but at the same time, the signals we emit are tending to get weaker as we develop. But an alien civilization that has much bigger radio antennas than ours, located close enough to us, might just be able to detect us. In an article, Seth Shostak, linked below, notes that evidence of our existence has already reached about 15,000 star systems, and if a civilization had a big enough antenna, he states, for example, one the size of Chicago, or may use gravitational lensing to look for us, they might just see radio evidence of us. The second main way an alien civilization might detect us is lesser known. Radio signals have always been the assumed way that aliens might pick us up, but there's another. We also produce a very unnatural form of visible light that if someone had sensitive enough instruments to detect it, and they would need to be seriously sensitive, they would know that intelligent life was the only cause. It's our streetlights on Earth's night side. In a paper by Abraham Loeb and Edwin Turner, they suggest ways that we might search for other civilizations by focusing on their artificial light emissions, and by extension, how other civilizations might look at ours. By looking at the night side of an exoplanet, if there is artificial illumination present, it would be different enough to be distinguishable from reflected natural light from the planet's star. The authors note that we currently could detect Earth-level artificial illumination only within our solar system. If there's someone hiding out on a Kuiper Belt object, we can detect their streetlights, but no further than that with current equipment. But as time goes on, our capabilities will grow, so at some point, optical SETI searching for the lights of civilizations should become viable. If it's possible for us, then it's possible for aliens as well. Another, more novel way aliens might detect us are concentrations of industrial chemicals in our atmosphere. In a 2014 paper by Henry Lin and colleagues, they detailed that we might look for refrigerants in exoplanet atmospheres to detect alien civilizations. This would be chemicals like CFCs. The aliens could likewise do the same with us, if they were close enough, and see evidence of very long persisting chemicals, such as those collectively known as freon. In addition to signaling active industrial processes on a world, the presence of these kinds of chemicals could actually serve as a kind of indicator. If you see only the longer-lived ones, it could mean that the civilization advanced past the use of those chemicals or died out. If you see the shorter-lived ones, you would know that the civilization was active. Maybe an alien civilization nearby has the capability to detect our radar or see our streetlights or chemicals, or perhaps one that is not yet close enough to receive our signals might someday pick us up. But I would speculate that it's pretty unlikely that anyone has, and the further away an alien civilization is, the harder it will be to detect us. Eventually, you just get so distant that you can't physically construct an instrument large enough for the task. This undetectability could be a good thing or a bad thing depending on your perspective, but what it does tell us is that a civilization at our level of development is very hard to see at a distance. A more advanced civilization should be easier for us to spot, and if they've been around a long time they would be detectable over greater distances, but it's really not something that is so easy as many might think. But while this may sound discouraging to those hoping for a contact type of numerical signal to come through, radio signals are not the only way an alien civilization might communicate with us. In fact, it may not even be the most likely way, we simply don't know. That same long period of Earth's atmosphere being altered by the presence of life also allows for another type of detection of us, and subsequent communication with an alien species. And this one would be far more direct and real-time than radio signals traveling long distance at the speed of light. In the distant past, someone in the Milky Way may have seen our oxygen atmosphere long before we evolved. They may have thought long-term and sent out a probe, a type called a Bracewell probe, at sublight speeds. It might have taken 50,000 years to get here, or a similarly long time. But the fact is, anyone wishing to study inhabited planets directly merely has to have good engineering and a whole lot of patience. We view time in terms of human lifespans, which are short but ever increasing, and there's nothing saying that they won't continue to increase until we live for thousands of years. Time and distance become less daunting in that case. Jason Wright of Penn State discusses this very thing in a recent paper linked below that points out that our solar system is ridiculously old, far older than our species to the tune of billions of years. It's been visible for a long time to the entire galaxy, and there's been more than sufficient time for someone to send a probe. Maybe multiple species have sent probes. Doing so may make even more sense than any other form of interstellar communication because while it takes time, it's at least direct on one end, and someday it may well wake up and establish contact. Finding such a probe before then would be a needle in a haystack, however, perhaps even harder than detecting a radio signal. With our current capabilities, we aren't likely to discover it should it be there. And of course, there are always going to be engineering questions, extreme age issues, self-repair questions, and so on with any sort of ancient Bracewell-type probe. Time is not kind to much of anything, so the aliens would need to have solved those concerns. But an advanced civilization long ago might have done that. Remember, the universe itself is even older than the solar system, and there could be civilizations out there that are many billions of years old. Again, we don't know. And even finding a dead probe would be useful. We ourselves have fixed plaques to our probes in case aliens ever run across them. Any active probe would have certainly watched us evolve and develop. In addition to collecting data on Earth, perhaps they've enclosed a copy of something like science fiction's Encyclopedia Galactica edition of 10 million years ago that tells us the secrets of the galaxy and the civilization that sent the probe. The information would be outdated necessarily, but information from an ancient civilization would still be excellent information indeed, and after enough time has passed, they too will get word from their probe that humankind has achieved civilization, and they can update their encyclopedia to include us. But there is one last unfortunate way that we might detect an alien civilization, or they might detect us. This would be if we, or they, destroy ourselves. In a paper by Adam Stevens and colleagues, they detail several ways in which we might detect alien civilizations that have recently destroyed themselves. The rules on that kind of a detection also apply to us, and while it may be a depressing way to detect an alien civilization, it's still a scientifically legitimate one. I'm a positivist, and I like to think that our first detection of an alien civilization will be an amazing experience, or it may even be a mysterious experience, such as the detection of some civilization's Dyson swarm but with no other information. That said, civilizations probably do destroy themselves, so we should know what to look for. The first way is through the detection of a nuclear war and its aftermath. Nukes produce a distinctive double flash of gamma rays in their detonation. In fact, when gamma ray bursts were first discovered, one of the possibilities on the table for their origin was alien nuclear testing. This isn't automatically a bad thing, actually. There are ideas out there on how to push a spacecraft to great speeds using hydrogen bombs as the propulsion method. Subsequent observation of GRBs ruled that out, however, and those things are far more powerful than any conceivable artificial detonation. But a big enough nuclear war itself should be visible at a distance if aliens destroy themselves, provided that they are seriously armed to the teeth. If we did it, however, surprisingly, it would probably not be detectable very far out due to reductions in US and Russian nuclear arsenals over the years. Atmospheric effects of such a war on Earth would be visible, however, at least for a short time. Nuclear war kicks up a lot of dust, and nuclear weapons produce a lot of weird ionization of the gases that make up the Earth's atmosphere. It's worth noting here just how powerful the effects of these weapons can be on a planet. The following series of pictures are from a nuclear test done by the United States called Starfish Prime in 1962. A hydrogen bomb was detonated in space, and it caused strange, bright auroras, along with an unexpectedly powerful EMP that knocked out power stations in Hawaii and wreaked lots of weirdness on the Earth's magnetic field. That test was probably not the best idea, and did have some long-lasting effects. In fact, it damaged a significant portion of the satellites in orbit in those days. That said, the entire solar system saw that one, and maybe further out did too, though the effects of a nuclear war anywhere it might happen in the universe would be pretty short-lived, and we, or the aliens, would have to happen to be looking at just the right time to see most of those effects. That's statistically pretty unlikely, but nuclear weapons aren't the only apocalypse that would leave a detectable mark. The paper continues to detail the effects of biological warfare, in particular if that warfare was cross-species and beyond devastating to an inhabited planet's biosphere. Specifically, assuming a world has anaerobic bacteria, distinctive, solely biotic chemicals would be produced by the decay of biomatter, i.e. corpses, and would be detectable in a spectrum for a time. If you detect it, it means life was recently there, but much of it may no longer be there. Thankfully, at least as far as what is public, no one on Earth has ever developed this level of biological weaponry, and in fact, biological weapons on Earth are pretty limited on purpose, and as far as we know, we can't destroy ourselves with what we have. Hopefully, cool heads will continue to prevail in this matter. But an alien civilization might not be so restrained. But again, this sort of biosignature would be very short-lived, and for us to see it with an exoplanet, we'd just have to happen to be looking at it at just the right time. But there is one last possibility that we might see with an alien civilization that they would not see with us, since this technology is still largely only hypothetical here. It's the gray goo, or molecular nanotechnology. This could be, if the engineering pans out, one of the most potent weapons in the universe. The idea is to create a self-replicating nanodevice that consumes matter to create copies of itself. It can do so on such a scale, exponentially reproducing, until it consumes a planet, or at least a large part of one. The author suggests that this technosignature would be visible for a much longer period than the others, on the scale of thousands of years. But I suspect that we won't see much in the way of apocalyptic markers in our search of the universe, and I don't think anyone will see them with us, or at least I hope so. But in the end, Earth is not really all that detectable to aliens, and aliens at our level of development would not be all that detectable to us. More advanced species would be, but there doesn't seem to be one of those close by, so I would imagine it's a good bet that no one knows that we're here. Yet. Thanks for listening. I am futurist and science fiction author John Michael Gautier, currently eyeing my wireless router suspiciously and wondering what it's telling the aliens. Loose lips sink ships, and be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.